Disclaimer: this video has very complicated equations. Viewer discretion is advised. Hey, Curiosity Hub, Gavin here. Today, we'll be talking about gravity, the force that pulls everyone and everything together. Before we get into the good stuff, we have to have a basic understanding of what gravity is. Gravity is an invisible force that pulls anything with mass towards each other. For example, the Earth has mass, which means it has gravity. In turn, that gravity holds everything in place, which means that we won't fly off the Earth into the vacuum of space. To calculate the force of gravity an object has here on Earth, you need to know the rate of acceleration. Here on Earth, it is 9.8 meters per second squared. Once you know your rate of acceleration, you can calculate your force of gravity. Simply multiply your mass by 9.8 meters per second squared, and there you go. Now you know your force of gravity. Gravity has some other cool properties too. There's a term in physics called terminal velocity. Terminal velocity is when a falling object can't accelerate anymore. It's going as fast as possible. An object will reach terminal velocity when the rate of acceleration, or 9.8 meters per second squared, balances out with the air resistance, or how much the air around the object is slowing the object down. The formula for calculating terminal velocity is v equals the square root of 2 times m times g divided by p times a times c, where m equals the mass of the falling object, g equals the rate of acceleration, or 9.8 meters per second squared, p equals 1.225 kilograms per meter cubed, or the density of air at sea level. A equals the projected area of the object, and C equals the drag coefficient. For example, if you dropped an average 2-inch diameter super bouncy ball off the observatory deck of the Empire State Building, then the ball would reach its terminal velocity of 112.654 kilometers per hour after falling around 100 meters, or 25 to 30 stories of a regular building. Have you ever asked yourself the question, how does gravity affect how living organisms operate? You probably haven't, but I'll answer the question anyways. Living organisms are affected by gravity in numerous different ways. For example, if us humans could live on the moon, theoretically of course, then we would have a lot shorter life expectancy than we would here on Earth. Also, if the theoretical moon humans had lived on the Earth their entire lives, then it would be safe to say that if they tried to visit Earth, then they would most likely die of heart failure before even landing, due to the Earth having 6 times the gravity of the moon. I hope you enjoyed this episode of Curiosity Hub. If so, then please like and subscribe for more great content like this. And as always, stay curious.